My name is Bharat. I've been with ThoughtWorks for about 4 years now. I'm a principal consultant here, and yeah, we do a couple of things along with leading the data and AI service line in operations. Cool. So now that the introductions are out of the way, I'll quickly talk a little bit about what my presentation is going to be about. Let me know when you can see my screen. Is the screen visible?
Yes.
Awesome. Cool. So I think you guys have heard a lot about what to do today in terms of what you can do with Playwright, what you can do from a test automation perspective. This talk is mostly going to be about what not to do, right? In terms of automation and things that people typically do in creating automation, test automation, or maintaining a test automation framework, and things that might appear to be very common sense, but unfortunately, they seem to be a recurrent problem in things that we see across the board. So all of these are from projects that I've worked on, projects that I've audited, and created assessments for. So whatever you see here is a bunch of learnings from there. If there are any questions, I'd like to take them at the end so that the talk goes through completely. Please do put them in the chat or the Q&A, and I'll be happy to get to it when we complete the talk. Cool. So in terms of these patterns and anti-patterns, I've kind of broken them down into two parts. The first being related to QA process. So when I say process, I'm talking about sensible defaults, things that people should be doing that is not necessarily part of your job description, but things that are expected from QAs. The second part are typical coding related issues. This is not meant to be a comprehensive list. These are perhaps some of the more common problems that I have seen. There are more, of course. It's just that, in the interest of time, I've just tried to pick on the ones that I feel happen a lot and things that can be easily rectified as well. Cool. So let's talk a little bit about what an anti-pattern is. So an anti-pattern is something that, is a pattern that should not be done, right? Something that goes against the grain of what is a good thing to do on a project. And, this is something that you should be very mindful of, because when you are mindful of not doing something, you would probably avoid doing it in the first place, right? So the first anti-pattern that I'd like to talk about is a common peeve of mine on a project. When people go through stories, when people are creating effort estimations for their stories, devs get their say in terms of how long it will take for them to create the code or the feature that they are developing. Typically, people also add a little bit of time for testing it as well. However, there is almost little to no effort or little to no consideration given for the effort that it takes to automate something, right? And it becomes a big problem going forward, because a lot of people just say, okay, you don't have time to automate this in this particular sprint. Let's just push it to the next sprint. And this part of pushing it out keeps getting, larger and larger, to a point where there is a huge push that is needed, from a team to start automation and start creating automation. This can be easily avoided if people start looking at, adding estimations in terms of how long it will take for them to create automation. Because it is not something easy to do. So it requires effort, it requires design, it requires planning, and it definitely requires people to put their effort into creating this as well. So if you see on your project people not considering time to automate something, please do make sure that you put that in. There is a good reason that people need to put time into creating automation itself. So if you see this happening, please make sure you talk about it and you think about what needs to be done in order to create the automation. The second part is an anti-pattern that typically is very related to the first one. We talked about how automation keeps getting pushed, right? And the reason a lot of people say that automation gets pushed is because they feel that there is not much you can do until the application is being developed, until there is something to test, right? So until you have something to test, people say, let's hold off on the automation, let's see how things turn out, and then start it. When you start doing this, this becomes a kind of a mini waterfall where you wait for development to happen, where you wait for testing to happen, and then you start on your automation efforts. Instead, it should look more like the following. When the analysis is going on, when the development is going on, you can start thinking about how you want to automate things. You should have an automation framework in place if you don't have one already, right? If you need to choose the right tool for it, please make sure that you pick the tool that gives you the best opportunity to start your automation efforts early. We heard from Nal, we heard from Anirudh, and we heard from Arun as well, in terms of various things that you can do to, quick start your testing efforts. So please make sure that, these things get taken care of earlier rather than later, because if that is not done, then you're going to run into issues finding time and finding the effort to actually start your automation. The third, anti-pattern that I'd like to talk about is not tracking a list of all the automation. People like to claim that they're writing self-documenting test cases. They like to say, hey, in Agile, we don't like to document things. You don't need to write too much in terms of what exactly you're trying to do. However, what happens is that it becomes very hard for new people on a project, or, as teams get jigged, or even later down the line, when people are trying to figure out what has really been done on a project in terms of automation, right? It becomes very hard to track automation. It becomes very hard to figure out how do you leverage what you already have to create, let's say, a regression suite, or to create a smoke suite, which can be run on earlier, runs of the application, for example. And it becomes very hard to do so unless you have a way to track this. Even bug tracking, for example, becomes very hard to do as far as coming up with root cause analysis, for example, because you cannot really tie your bugs to a particular activity. You cannot tie it to a particular, people tie it to stories, for example, but when you're testing it, bugs usually come out of that. So if you are not able to tie it to an activity, it becomes very hard for you to have a complete flow in terms of what needs to be done. So keeping a minimal list of automation is a great idea, and I think all test management suites that projects use today have a way to do this. Even if you do not have a test management suite, using your project management suite and perhaps tagging a particular test is very useful. Another way this is very useful is also to keep a track of what is automated, what is not automated, because if you have to figure out how much work exists as far as the automation is concerned, it is very important to know what quantum of work you have to complete your automation, right? And you might decide that certain tests are not worth automating, certain tests need to be automated later on in the process, for example. So these are things that need to be tracked. And if you do not do so, it is going to be a little difficult for you later on to create a complete list, because again, the quantum of work that it takes to actually list everything, to create the links that are required, and all of these things are very important. So all of these activities can typically be done while the development is going on, or while the initial testing efforts are going on. So later on, I'll talk a little bit about what are some ways that we can create a quick list of these things, and how do you create a visual method to perhaps track all of these automation and maintain it easily. So we've talked a lot about the test pyramid. I think everybody knows what that is. However, conforming to the test pyramid, or making sure that people are disciplined enough to use the test pyramid, is something that very few people do. Unfortunately, the test pyramid ends up more in a cupcake form, or in a inverted cone, or a square form, right? Where the kind of test that you're doing is not being done at the optimal level. I think Nal and Anirudh talked about it in the previous talk as well, where you need to push your test down as far as possible. However, this is something that is not happening. I won't spend too much time on this because it's already been talked through a couple of times. But please do make sure that you are running your tests at the right layer. Right. So, typically when you talk to your clients or you're talking to other participants in a team, uh, what everybody tries to say is, everybody gets to a point where, we need to get maximum automation. And usually, if it is easy to automate something, people typically try to over automate something, uh, or they try to, set a very high bar in terms of, an automation coverage perspective. However, this is not really required, right? When you are trying to automate uh, a test suite, for example, you need to be very careful about what returns you're getting from that. uh, Calling out the right candidates to automate is a very important part of the work that you need to do before you actually get started writing code. You need to spend time on deciding how much automation is required for a particular component, for a particular level, for example, so that you don't spend your time unwisely. You have to spend the required amount of time to get the required amount of automation, not more, not less. The reason for that is that when you start automating too much, you also need to keep in mind that you have to maintain and extend that code. You might have to create test data for that new automation. You might need to create new, you might have to write a lot of code for the extra automation that you have to do. Having 100% automation is not a measure of success that you should have in terms of automation. Having a measure of success in terms of what should be automated is your success mark. And if anybody says otherwise, please do push back saying that, hey, we do not need to automate this either because it does not give us the required benefit of automation. It does not make sense to automate, or it is perhaps something that you cannot automate at this point in time. The reasons could be tied to data. It could be tied to the time it takes to write something. Could be the the support that you get from your framework and other resources to be able to create that automation and maintain that, for example. So please make sure that when you are creating a test suite, make sure that you mark how much automation is really possible. And again, this ties back to the part where you're actually tracking what tests you have, because you need to say what is automatable, what is not automatable. So, uh, how much tests should you have? What are the optimum number of tests that you should have in your test suite, right? Just having tests for the sake of having a check mark against your testing is not a reason to do automation. You need to have automation tests that are likely to catch bugs. So you need to make sure that you have high powered tests. A high powered test is something that is more likely to catch a bug if there is a problem with the application than otherwise. So if you are creating a lot of tests just for the sake of automation, please do not do so, because you are ultimately, creating a lot of work for yourselves and something that you would not be able to maintain or extend. So make sure that, you have a few tests, but those are very high powered tests and likely to catch, any issues in your application if possible. So I'd like to spend a little bit of time here. So we talked a little bit about what is a way to keep a track of all your tests. What is a way for you to mark what is automatable, what are good tests or high powered tests that you need to run, right? Uh, Creating a visual for yourselves in order to capture all the things that you can do from a testing perspective is very helpful. And again, something that you should be doing as soon as the story and the acceptance criteria has been created, because you don't really need the product to work for you to be able to come up with a visual like this. So I've done this in a couple of projects and I found this very helpful. So what you do is you take a story, you break it down into the primary components. So for example, in an API, for example, you would want to test your requests, you would want to test your backend, you would want to test authorization, perhaps logging, security, maybe performance, for example. And for each of these, you can create some basic tests very quickly. So you might have data setup tests, you might have tests that are concerning your method itself, the config, anything that you want to create, right? You create this, and you can use this for your dev box. You can use this as a way to show the work that you are actually doing, and you can mark tests that are automated or or not automated in a manual sense in a way, right? So the stick figures that I have here, for example, are tests that I would want to do manually. It does not make sense for me to automate those. The green ones are positive tests, the red ones are negative tests. I might not actually create all of these, but these are all various situations that can arise, for example. So in a dev box, I might choose to run some of these. I might not choose to automate all of these. However, everybody in my project is very clear on what is it that I am going to be testing on a story. This perhaps takes about 10 minutes to come up with, but it is invaluable for me, going forward, because I know exactly what I need to do. And a mind map like this, for example, is very easy for me to, change as well. So if there are requirement changes, I don't need to go to some dusty old document to change things. I can just come here, add or delete a couple of nodes, or change a couple of nodes, and everything gets done. I would strongly, recommend that you use a tool like a mind map, for example, to keep a track of all your tests. And this also, helps you, you can create links over here. For example, if you're using Jira or any other test management tool, you can directly link to the test cases that you're creating from here. So it becomes like a one-stop shop for everybody to take a look at. Even if new people join, they can take a look at everything that exists over here, and make sure that people are aware of what's being done, how things need to be recorded, tracked, etc. You can go even one step further and perhaps even create links to data, or if there's something that people need to learn from a prerequisite perspective, from a domain perspective, you can link to information here as well. It is very clean. It is very easy for people to do this. So please do think of ways to make your work easier, but at the same time, make sure that you are transparent about what you do, and make it easy make it easy for people to track what you're doing as well. So this works from everybody to upper management to lower management. I can tell you that this was loved a lot, and the client that I worked for took this and uses this as standard fare for all the testing that they do. Right. So I talked a little bit about the process related, patterns or anti-patterns till now. So these are like things that I feel are very easily rectifiable. There are more, of course, but I'm not getting into those. If there are any questions that you have about any anti-patterns that you have seen and want to talk about, I'm happy to discuss that. I'm sure, some of our panelists here have a lot of experience in that as well, and they can probably contribute to that conversation as well. Cool. So, the biggest pet peeve that I have from a coding perspective is that, people treat test code as second-class citizens, right? The amount of thought and effort that goes into creating and maintaining, test code, it does not get the same, does not get the same treatment as perhaps, proper code that somebody writes. And I've never understood why, because ultimately, the testers who create that test code are the ones that are typically going to maintain that test code. If they do not design it well, if they do not think about what is the best way to create a framework or my test suite properly, it becomes very hard down the road to extend my test suite, to maintain my test suite, to separate the data from the code, for example, so that it makes it easy for me to maintain my test data, maintain my code, etc. Right? And one way that anybody or everybody can use to do this is to make sure that you follow the solid principles. I won't get into this because that by itself is a topic of its own, but please design and treat your code well, right? Please design and treat it for extensibility, for maintainability, not just to get the job done. Fine, you want to get something quick and dirty just to get the process started is okay. But, please do invest time and effort into maintaining your test code and your test framework as you would, normal dev code as well. And, Solid goes a long way in terms of making sure that all of these are done properly. Another, anti-pattern that people have is to use wet code, right? So wet has a lot of, expansions. So it is, write everything twice, or we enjoy typing, There's a lot of expansions for this, but basically what it means is that people use, people duplicate their code a lot. Whether it comes to, and the reason for that I've seen typically is because people feel that, if you copy paste, you get your testing done quickly, or you can create your test suite quickly, right? Uh, and this is usually done as a temporary measure to just get the process started. However, unfortunately, what happens is people, kind of just lean into it and continue doing this all the time. A classic example is like with a util file, for example. You might structure your code well initially, but you find that the existing utils class does not completely meet your needs, or you feel that it is becoming too long. So you create another utils class, which almost does everything that the first one does, but has something a little bit different. So a lot of the code needs to be replicated across both classes or objects, right? So what happens is that when you keep going down this path, the code starts becoming unmaintainable, right? So please make sure that you are refactoring your code constantly to make sure that you have the most optimum code possible. You try to write everything once, and only if there is an exceptional circumstance, you try to replicate something. Another common action is that in test classes themselves, for example, there are multiple actions that can be refactored into common methods, like but they do not get done because, like I said, there is a lot of copy pasting that typically happens when people write classes, for example. So please make sure that if there is something that you can refactor, and usually people use a rule of three, where replicating something once more is okay or acceptable. But the time that you have to replicate something a third time, then you have to start writing a common method that can do something that is done across multiple methods, for example. So please make sure that you do this, and please keep your code dry. So the opposite of wet is dry, which basically means don't repeat yourself. So please make sure that you follow that principle in order to have a well-maintained, robust framework. Right. Another big anti-pattern that people typically follow, and this happens as the project goes on, as people keep getting more and more work to do, and the product keeps changing, is to keep continuing your existing test cases to kind of take on more and more responsibility. Uh, a lot of people think that by writing bigger and bigger tests, they reduce the number of test cases that they have. But unfortunately, what happens is that it only starts making the code brittle. It starts making the code too complicated for people to follow. And you probably will be violating any of the solid principles that we talked about earlier. So in this example of code that you see, there is a timeout at the end for almost 3 minutes, which needs to be there because that's how long it takes the test to run. And you want, the nothing else to run while this test is running. So what happens is that your timing for your automation suite running gets thrown off. And a lot of fragility comes into the code that you're writing as well. So when you are creating tests, please make sure that as you extend your code or as you keep maintaining your code, you break your code into the minimum responsibility possible. Try to keep it as close to single responsibility as possible. I know that sometimes it is not easy to do, especially as you have, one or two things that are dependent on, let's say, previous results and things like that. But try to keep it, as single responsibility as possible. Keep your tests as small as possible, even when you are testing at the integration layer, or unless you're getting into a user acceptance test where you have to write a complete end-to-end test. Please make sure you're not calling more than one thing in your single test. That way, it makes it easier for you to debug. It makes it easier for you to set up and tear down a test, for example. And your test suite will also run as quickly as possible and give you an error as quickly as possible as well. Right. So, we talked a little bit about unorganized test frameworks, right? So what is a good test? What is a good pattern to have for your framework, for example, right? So if you look at a well-designed test framework, you would typically have 3 different layers to them. You can create more layers if you want, but in my opinion, these 3 layers are good for encapsulating what your test framework should be like. The top layer is your test code, right? Is anything related to actually running a test. There are various actions that you would perform in your test. All of that would be in your test code. And all of these should derive from a base test that you should be writing, which would be the model or template for all your other test classes. You should have a utils function or a set of utils functions if there are multiple things that you're doing. And you should, of course, have your test data that correlates to the code that you're running as well. All of this should be purely transactional. It should not have anything to do with the domain or the business logic. All of this sits in another layer or should sit in another layer. So your scenarios, which calls on your various test methods, which calls on various things that you're expecting your automation framework to do, should reside in a separate framework. This could be a different class or whatever way you would like to separate this, way out, right? Even your validation of rules, which are based on your domain, for example, should sit outside. A lot of people try to mix this in with a test code, especially in your assert statements and things like that, which makes it, bad, because when your requirement changes or when something changes, it becomes almost impossible for you to figure out where all you need to go and make those changes. If you're clearly separating out your business logic from the test code itself, where you're just performing actions, it makes it much easier for you to extend and to maintain your test automation framework. You also should be looking at creating a scenario config separately, which relates to this as well, which captures all the important data that is related to the scenario or the business logic that you're trying to. All of this should again be separated out from the test runner and anything related to the automation tool that you're using to create your tests. This way, you're making sure that when something goes wrong or something needs to be updated, these are well separated out in a way that makes it much easier for you to, take care of your automation, take care of your, your code itself. So we talked a lot about test data already. I won't cover that too much in detail, but basically what you should do is not use the existing test data that you've been using over a period of time. Please do keep refreshing it. I think Aniruddha and Nal talked about a bunch of different strategies that you can use for this, but please make sure that you use, up-to-date data, that you are aware of what data that you're trying to use, and that it makes sense for the testing that you're trying to do. A lot of tests constantly fail because of data issues. And this is because people don't realize that the data that they're using is either old or obsolete. So please make sure that before you start your test, you can set up all of these. And again, these are activities that you can or should be doing before you, have to create the automation for this. You can design, create, and design and create your data much in advance so that you are not spending time during your automation efforts creating all of these. And this would be very useful for you to do manual testing or your dev box testing as well. So please make sure that you can create all of this data upfront. Another thing that I've constantly seen when I look at or do code reviews of people's test suites and stuff like that is that assertions are not used properly, right? And assertions are like pretty much the reason why we write test code. We want to make sure that when we are doing a set of actions, there is an ultimate end result that we want that needs to be seen or observed, right? And there are multiple categories of assertions being used incorrectly, but these are probably the ones that happen the most. So first one is a case of manual assertions, right? So people create a test class or a test method. They perform a bunch of actions, but they never use the assert function at all. They create their own if-else functions or some other way of validating something. People sometimes even just write to the log saying that these are the output values that I've seen, but they never assert anything. You might think who does this, but it's very common and people do this a lot. So when you take a look at please do look at your dev code as well, your developers code as well. And I'll guarantee that you will see quite a lot of code written in this way. where people do not use asserts at all. Please make sure that in your project, people are using assertions properly, that they are using the right assertions as well. The second, kind of anti-pattern that people use is trying to assert too many things in one function, right? It is very key for you to identify what makes a test unique. What are the parameters or what are the data values that make your test unique? So please do not use too many, asserts in a single function. Sometimes it is unavoidable, especially if the data that you're getting back is very large and there are multiple mandatory fields or things that you want to check. Try to break them up into different tests if you can. Again, from a fragility, from a maintenance perspective. However, please try to keep, the number of asserts that you have minimal. If you have too many asserts, try to perhaps create that in a separate function of its own, or create a custom assert function, so that you make your test readable. Having too many asserts in a function also makes your test unreadable, because it makes the test very long, and somebody who has to maintain it has to come and make all those changes again. So keep these in mind when you are trying to create your test as well. The last one that I'd like to talk about is using the wrong assertion. A lot of people only use assert true or assert false. There are a number of assert functions that you have that are used for different situations. Assert equals, assert null, assert not null, etc., which are all provided by your library. Please make sure that you use the correct one as required, because what happens is that when you use the incorrect ones, it becomes very hard to, if something changes as a requirement, for example, you need to go and make a whole change for the condition itself. But if you use the correct one, it first of all is more readable, and second of all makes it easier for you to maintain as well. So last, I'd like to talk a little bit about, pattern. We talked a lot about handling test data. So a couple of things that I'd like to talk about: providing data to your testing from an automation framework perspective. Please try to handle, dynamic data or your parent or your short secret data that you cannot store anywhere, through, user input, for example. Try to use this through parameters. So an example here, for example, is the suite that I want to run. I want to specify that at runtime. So rather than, putting that as hard-coded data somewhere, or, trying to run a particular class, for example, try to put that in as a parameter, a runtime parameter. A second way is, a lot of people need global data to be present across different tests. If you do need to do that, try to use properties files. A lot of people do that, but make sure that your properties file are also segregated, into relevant functions, so that it becomes easy for you to make changes going forward. And of course, when you have data that are constants, it always is good to keep them in a separate class that does not get extended or initialized going forward. So, these are some, quick tips to make sure that, the data that you're handling in your class or in your different testing scenarios gets done properly. The last one that I'd like to talk about is making sure that you're, changing, your test cases as the requirements keep changing as well. So what happens is that, unfortunately, as requirements keep changing, the test cases also need to keep changing. And it becomes very hard to do that if you, first of all, don't have a list of what you are creating, if you do not have a list of what is automated and not automated, and if it is not designed well, which makes it easy for you to go and make changes. The reason that this typically happens is because of the reasons that I've listed. So if you are maintaining your code, please refactor to make your test suites more extensible and all of your other work more extensible, which makes it easy for you to keep up with your requirements. Cool. So that's all the gyan I have to give to you folks today. So I'll stop talking and see if there are any questions for you to answer. Any comments or any other patterns that you guys have seen that you'd like to talk about also would be great.
Any questions, anyone? You can post it in Q&A section.
So there's a question that says, is it good to keep data in an Excel file and pull it as and when required? If your test data requires data in a tabular format, uh, I probably would not choose Excel. I might use a textual format like a CSV, or maybe even store it, get it from a database. So I would say, try to use those because it has less overhead. It's easier for you to maintain. Doesn't require any extra libraries for you to install, unless the framework that you're using gives you, the ability to handle Excel files, for example. If you do want to use Excel, I think CSV is a good choice for you to use.
There is one more question in chat section. If I have an API to test which take huge JSON payload as an input, how should we maintain different payload to test different cases?
So the best way to do this would be to have a template payload, which outlines all the mandatory and perhaps important optional fields that you might want to use. So when you pull in this template field, you can make changes to the data that you have to send and as a request, and the response can be saved as a template as well, right? So that you're checking for correctness of structure, of schema, and all of that. So these are things that you can do. So please do store your JSON. You can store a sample data, for example, as a template, so that your entire structure is as required. And as you're running your tests, pull the template in, make the changes required, and send your requests and this thing. With that, I hope that answers your question. But please do keep different templates if you have different structures for the same API. So if there are a lot of optional fields that you want, for example, so you might have a different template for each of those, but keep it as a minimal template for a particular test so that you're not adding extra work for that. In terms of what libraries you can use to read CSV, depends on the language, depends on the framework that you use. But I think almost all automation frameworks have a CSV or a TSV, or any separated value function. So those are all already available. Your language should, Stack Overflow is a good source for you to go and see how to parse a CSV file in the framework that you're trying to use. You said business rules have to be kept outside test code. Can you please elaborate here, provide some examples? Okay, so if you have a cart, function, for example, and you need to test the cart, there are certain rules that are perhaps specific to a particular country, for example. So in India, let's say Aadhaar, I'm just giving an example here. Aadhaar might be required to buy certain products, or a PAN number might be required to buy certain products. But if you are buying it in the US, you probably need to provide your SSN, for example. Now the function of adding a product to cart will be the same for both countries. However, the data requirements for both, or the rules to be able to add certain products for both, are different. So these are business rules that need to be separated from the test logic that you do. So Walmart, for example, might have a page for India, might have a page for the US. But they will require that business logic of checking for that ID to be very different for both. So that has to be from a scenario perspective, or the validation has to be done outside of the action of adding something to cart and adding it to, or maybe checking your cart. So that would be your base function, whereas your business function would be checking the ID itself. So that is an example. Can we use a Pojo class approach for, I'm not sure what that is for. So what is the Pojo class approach for?
It's just like, having the creating the Java objects out of the API payload to, just create the Java class and convert that into into
Yeah,
different Java objects with different values.
you can do that, but I found that to be too much work. So what happens is if the payload changes, then you have to go and make a change to the code itself, the test code itself. However, having a template that you read in and having a method that relates to that template, if you have multiple structures for the same API, for example, makes it easier for you to keep a track of everything, right? Uh,
Yeah. Yeah.
because yeah,
Yeah.
sorry.
There is another kind of scenario where we need to have like different payloads for different scenarios. Like in one of the payload, we require all the mandatory fields. In some of the other payload for other test cases, we need all the mandatory plus couple of optional parts. So for that, in that case we have to like create multiple templates that can be in the form of JSON or that can be in the form of the XML. So whereas in the Java object, if you create like multiple classes, Java classes for the different templates, and you just have to create an object with all the values. Both the approach I think is same. The only thing is in the first case you have to create multiple XML files or JSON files. In the other case you have to like create multiple class. So it depends on the class resources also, how much, because the classes do take more resources rather than creating a JSON file when you are like actually processing it, or you are running it using JRE or something.
So there are two more things I would like to add to that. So one is, yes, the classes do to it take more overhead, but it also, any change in the uh, structure of the API, for example, requires a code change, right? Which would need to be rebuilt again. However, if you are just handling your files, it does not require code changes. So it is easier for you to do, and anybody can make those changes. So how you want to approach that is up to you. If you want a strict rule to be applied and you want to have very strict control of the object that you're creating, Pojo works great. If you are trying to handle multiple scenarios where you do not want to touch the code too much, but you want to look at the data and the changes in the data, then you can perhaps go with having multiple data templates. The way that you want to do it is completely up to you. I personally prefer not doing it through code because again, that becomes something to maintain. Because not only do you have to maintain the data, you also have to maintain the Pojo, right? It is a
Yeah.
two-time.
Yeah,
So in that
makes sense.
sense. The next question, any pattern that you would follow to compare JSON template? I think you mean tool to compare. So I think Jackson is a great tool that you can use to parse and work with JSON files. Uh, I don't know of any design patterns that would probably be applicable here. Maybe if any of you folks have found any design patterns useful in this sense, we could probably talk about that.
I think we don't have any kind of design patterns. It's just the libraries which you can use based on your language or based on your approach. So just like what Bharat said, like we can go for JSON, we can go for uh, uh, you know JSON is there, Jackson is there. There is one library which is a part of JSON dependency itself, but you don't have to add another library for comparing two JSON templates. You have that feature available in your JSON dependency itself. So if you can use that one which is internal to JSON, that is also fine. If you want to use third-party external library, that is also okay. But we don't have any kind of pattern which we need to use. It's just a matter of creation of functions.
So just to plus one to what Tushar said, one more thing is that if you are comparing the template, then creating a Pojo and using the Pojo is very useful. So basically creating a plain old Java object where you are converting the structure into attributes and functions makes it much easier for you to take a look at all of that. So code coverage is one of the anti-patterns I did not talk about today. So code coverage is a good hygiene metric to have, but it should not be the be all and end all of your automation that you're doing. A typical industry, accepted average is about 80% for your code coverage. But that goes back to the anti-pattern where I talked about, just having a certain set of automation as a check mark against your code, and not making sure that the code that you have is the best to find bugs in your system if possible. So use code coverage, but do not use that as a silver bullet or to say things are all okay. Maybe that is one of the data points that you should be using for measuring the quantity of tests. Again, quantity of tests by itself is not a good measure. Please make sure that you're covering all the important functionality, and that is where visualizing what needs to be run to find issues against the story that you're creating the automation for is very important. So yeah, and the last one is increase the number of tests to increase coverage. Can it be a criteria for increase the number of tests? Again, don't go by coverage. If you have a list of tests that are most likely to get you or most likely to find you bugs in your system, you are going to be better off by looking at what you are testing rather than the coverage itself. The coverage is a good starting point, but that should not be the only measure of what you are testing. What I found useful is against a component, I will keep a target in terms of how much of my tests should be automated. Because I would have, let's say 20 tests, I would say 15 tests is what I need to get automated. 5 tests, I will not automate. So, that 75% value would be valid for that component, and keeping that across all your different components would be a good way to, check on that. How is the screenplay pattern good compared to page object model? Completely dependent on what you're trying to do. So I am not aware of what screenplay pattern is, but page object model is great for UI based automation, especially if you're trying to separate out all the components on your page from the actions of the page. And that is kind of going back to the part where I talked about having the different layers of separation. A page object pattern is a way to separate the business logic out from the the actual code itself, which is doing some things, right? So in your test code, if you're using a UI automation tool, you would say, go to this URL, click on some component, find some element and do something. Those are actions. But what you are finding, what you are clicking, all of these can be hidden in the page object model from a business perspective. So all of the fields, the names of the fields, all of those kind of things are a good way to separate out the the business logic from the test code and the logic for the test itself. There's one more. How do you make sure that the developer's unit tests are correct? Because there may be cases where nothing is asserted or tested just for the sake of code coverage. Yeah, so that is not a good thing to have, right? If you're creating things only for code coverage, then you're giving more importance to the number of code coverage rather than what you're actually planning to do. So if test cases are empty, they should be removed. They should not be there because that is a problem that is waiting to happen because you think that something has been tested based on the name of the unit test case, but because something is not being asserted properly, and a lot of people sometimes just have system.out.println statements to print something out or something like that, right? And all of these are building blocks to failure going forward. So you can code review developers code as well. There is no reason for you to say that because I'm a QA, I do not have to review something. So please do that and make sure that you are looking at code. If you see this problem, bring it up. That's your responsibility as a QA.